It's one thing to teach an AI to be helpful, but what about teaching it to be helpful, safe, and follow specific formatting rules all at the same time? Well, that's a huge challenge. But researchers at NVIDIA just found a hidden flaw in how we've all been doing it, and their fix is surprisingly simple with some pretty massive implications. Okay, let's get into it. So this breakthrough comes from a team at NVIDIA, and they were looking right at the very foundation of how we get these big language models to align with what we want. And what they found was something that, believe it or not, pretty much everyone else had missed. And this really is the core of the problem, isn't it? We don't just want an AI that spits out the right answer, we want that answer to be brief. We want it to follow specific rules. Maybe we even want it to avoid certain topics. So how in the world do you get it to balance all of those competing goals during its training? Yeah, this is what the experts call a multi-reward optimization problem. The AI gets different reward scores for all these different behaviors, and the main goal is to rack up the highest total score possible. But as it turns out, the way we've been adding up those scores, well, it's fundamentally flawed. The go-to method for this whole process is called GRPO. It's pretty much become the industry standard because it's simple, it's efficient, and it works. Or so we thought. I mean, this has been the workhorse for training so many of the models we use every day, but it has this secret little weakness. And that weakness is what the NVIDIA team has dubbed reward collapse. It's a really subtle but absolutely critical issue, where the training process is actually losing vital information. And that leads to AI models that are less effective and sometimes just plain unstable. Now take a look at this because it visualizes the problem perfectly. Under the old GRPO method on the left, you can see how totally different combinations of rewards, like, say, a low score for correctness but a high score for formatting, end up getting crunched into the exact same training signal. All that nuance, all that important detail is just lost. Think of it this way. It's like a recipe that just says, add 3 cups of mixed dry ingredients. You have no idea if that's mostly flour or mostly sugar. The ratio is completely gone. That is exactly GRPO's problem. It adds up all the rewards first and then looks at the total, causing this reward collapse. So what's the solution? This is where NVIDIA's new method comes into play. It's called Group Reward-Decoupled Normalization Policy Optimization, or thankfully just GDPO. And the idea behind it is just brilliantly simple. Okay, now let's shift over to the right side of this image and see how GDPO works. Instead of mixing all the ingredients together right away, GDPO analyzes each one separately. It looks at the correctness reward and the formatting reward on their own terms before it combines them. So the key takeaway is that all that valuable, granular information is preserved. So it really just breaks down into 3 simple steps. First, you normalize each reward signal by itself to see how it stacks up. Second, you add those clean, meaningful signals together. And finally, there's a quick stabilization pass just to make sure the numbers don't go haywire. That's it. It's such an elegant little tweak to the recipe. And here's the impact of that simple change. By keeping the signals separate, GDPO can create up to 3 times more distinct training signals from the exact same inputs. That means the AI gets a much richer, more nuanced understanding of what we actually want it to do. Of course, a good theory is one thing, but the real question is always, does it actually work better in the real world? So the researchers put GDPO in a head-to-head competition against the old GRPO method on a bunch of really tough tasks. The first test was in something called tool calling, where the AI has to be both correct and follow a super strict format. And as you can see from that green line, the GDPO model learned faster and it hit a higher peak performance for both the format and the correctness. It's a really clear win. But this is where it gets really dramatic. On a challenging math reasoning task, just look at what happens to the GRPO model on the left. After about 400 training steps, its performance just collapses. The model actually starts getting worse. In contrast, the GDPO model in green stays rock solid, and it continues to learn and improve. This is a huge sign of a much more stable and reliable training process. And the hard numbers here just make it undeniable. In this head-to-head on tool calling, GDPO gets higher average accuracy, and it gets the format right more often. This isn't just a little bit better, it's a consistent and really measurable improvement. So, why does a technical fix like this matter to all of us? I mean, it's not just about getting slightly higher scores on some benchmark. No, this is about the fundamental reliability of the AI systems that we're all starting to depend on. So, the bottom line is this: GDPO prevents those dramatic training collapses we saw, and that leads to AI that's way more stable and predictable. It means the AI is far better at balancing competing goals, like being both helpful and harmless. This is a foundational improvement for building AI that's more robust and truly aligned with our complex human values. And this just leaves us with a fascinating thought. This wasn't some giant leap in AI architecture or a massive new data set. It was a small, clever change to the training recipe that had a huge effect. It really makes you wonder, what other simple, powerful ideas just like this are still out there, hiding in plain sight, just waiting to be discovered?